of Mars. And that thermal infrared camera, right side, it has taken the picture how hot at different place Mars is. It's a cold planet. Its maximum temperature is around 21 degrees centigrade, and minimum is minus 128 degrees centigrade. And this image was taken by thermal infrared imaging system, and it is in 7 to 13 micron infrared band, infrared frequency band. And then we see clouds also on MOM. You can see the down left side, whatever picture you are seeing, this one, that is Olympus Mons. On that, there is a white patches are there. That is, they are actually thin clouds, whatever it is captured by this. This was captured by Mars color camera. And the right side you are seeing is showing dust activity, that is the whole region, how the dust storm is taking place. So these all are the very important data. To suppose sometime tomorrow you plan to go in a certain, sorry, it has you want to make a colony in Mars, where exactly you should land and what you should see. And by the way, this the temperature data, whatever I told you, what was taken from thermal infrared camera, that is actually validated by the Perseverance rovers is there right now, no? So that is taking on ground temperature, and that is almost getting similar data there. That is NASA's robot right now traveling on Mars. Okay, now these are the technologies I told you till now, whatever we had with that we have worked. Now we need to go to a newer technology, like see, suppose when you are imaging something, you are actually sensing the radiation from that, and you have different types of sensors. That is what is called infrared camera sensors, or the normal visible range camera sensor. Now suppose you have a very low illumination, and in that time you can actually picture it. That is the energy is too less. We call it single photon detection. Now how light is? Now we have got light, ordinary light sources by which we take picture. We have laser source by which you know what a laser source is. Normally you have all laser pointers nowadays. And then we have quantum light sources. Now quantum light sources, basically they are single photon sources. Now we treat light as photons, not as waves that much. Now in all these three cases, how they look like. So if you have a normal light, you see the bottom completely where my, you can see this. This is how the photons look like, how they are traveling. And when there is a laser source, there is certain number of repeativity and regularity is there. But when you go for a single photon source, that is, it is emitting photon one by one, and there is a complete correlation between how they are getting emitted. Now, suppose if you want to sense these single photons, you need to make a single photon detector. This is one part. And another is when you talk about a quantum particle, there are normally, because most of you use, at least in up to +2 level quantum physics background you have. Now you have two things which is very weird in quantum mechanics. One is superposition, that is, it can be in many states at a time. So suppose if you talk about a polarization, light is having a polarization. Now it is having all the polarization existing simultaneously till you measure it. And another is entanglement, quantum entanglement. What is entanglement? Described by single wave function. That is, now this was, Einstein was very much puzzled by that. So